Have you ever wondered how the space agencies land on the moon with their spacecraft? In this video, I'm going to explain in particular the landing of the Nova C spacecraft of Intuitive Machine. But first, remember to leave a like and subscribe, so I can bring more interesting videos.
2, 1, ignition, and liftoff. Go SpaceX, go IM-1.
For first thing, after building the lander, was needed a rocket powerful enough to launch the probe to the moon, and for this launch was selected the Falcon 9. That sent successfully the lander into a trajectory to our natural satellite, the moon. After separating the first stage and the fairings, the Falcon 9 ignited the second stage, sending the probe in a highly elliptical orbit and separating it from the rocket. From this highly elliptical orbit, called lunar transfer orbit, the lander made a series of tests of the instrumentation, some trajectory correction maneuver, and made a series of photos of the Earth while it was approaching the moon. The probe stabilized its pointing thanks to some star tracker and its RCS while approaching to the moon, and meanwhile it corrected its hyperbolic trajectory to insert itself in a lunar polar orbit. The probe, after arriving to the moon, it redirected itself in a retrograde position to slow down to its closest proximity to the moon, igniting its motor, and insert itself in a low polar lunar orbit to land on the South Pole. After arriving in the lunar orbit, the probe made some tests on board, preparing to the landing. While the probe was in orbit, even made some photos of the lunar surface, and at the right timing the probe slowed down and another time to deorbit and execute its final descent. While the Nova C lander was descending, it started the terrain relative navigation with a laser instrument to locate a good landing spot and ignite the main engine to slow down and eliminate the horizontal speed. After having eliminated the horizontal speed, the probe executed a pitch-over maneuver, starting the vertical descent, and with the sensors started to redirect and avoid hazardous point with his RCS. In the final vertical descent, the probe eliminated the vertical velocity and maintained a speed of 1 meters per second until the landing. After the successful landing, the probe started to communicate with the ground station to confirm its landing and started to operate to complete its scientific mission. Thanks for watching. See you in the next video.